Hello everybody, it's Mrs. Pound and I am back with a new chapter, chapter 1.3 about rocks. We just finished talking about minerals. Now we're going to talk about basically mixtures of minerals. So the first section, 1.3.1, is about igneous rock. Our objectives for this section are going to be to define and identify igneous rock, describe how the cooling rate of magma affects the texture of igneous rock, and to classify igneous rock according to mineral composition and texture. One thing we have to know about all rocks is they are classified by how they are formed. And there are three types of classifications. Now, the first one we're going to talk about, the igneous rocks, they come from magma. This is the melted rock beneath the Earth's surface. Very high temperatures and high pressures cause the rock to melt. Lava is magma that has reached the Earth's surface. So it's magma under the surface, it's lava on top of the surface. Igneous rock is a rock that formed from cooled and hardened magma. Two kinds are intrusive and extrusive that we're going to talk about. Now, what you see in the background is actually the core of a volcano. The outside of the volcano has been eroded and carried away, and it left the inside core that hardened. So, a pretty cool igneous rock. There are two types of igneous rock. They are felsic rock and mafic rock. Felsic rock is a light-colored, lightweight igneous rock that is rich in silicon, aluminum, and potassium. And so granite, which is in the background, is a common felsic rock. It's light in color. Mafic rock is the dark-colored, heavy igneous rock that is rich in iron, magnesium, and calcium. And you can see some more igneous rock that is an interesting pattern. The way it cooled, it has formed these interesting geometric shapes in the background. Now, one thing that is also interesting is the felsic rock, for the most part, is what the continents are made of. Mafic rock is more what the ocean floor is made out of. And when we talk about plate tectonics, this will play a role in that, which is really interesting. There's another way to describe igneous rocks as well. It's whether they're intrusive or extrusive. Intrusive rock is an igneous rock formed when magma cools beneath the Earth's surface. And most intrusive rocks have large crystals because they cooled slowly. Again, there's another sample of what looks to me like it's probably granite in the background, and you can see these large crystals forming in it. So granite is an intrusive igneous rock. Extrusive rock is an igneous rock formed when lava cools on the Earth's surface. And most have small or no crystals because they cooled quickly. So to keep them straight, intrusive interior, think. Extrusive exterior. Okay, to keep those two words separate. And here in the background for my extrusive rock, I have a piece of obsidian which has no crystal structure at all. It cools so quickly on the outside of the Earth's surface that actually we call it volcanic glass, okay, because it literally looks like a piece of dark glass. Now I'm going to switch over to my camera because I want to show you where you can find a lot of this information in your reference tables. Okay, so here I am on page 6 of your reference tables. And we can see that it says Scheme for Igneous Rock Identification. This is at the bottom of the page. And it has a lot of the words that we already talked about here. And here is the whole thing. But let's start up here. So we have our igneous rocks. The environment of formation, we have extrusive, which they have volcanic in parentheses, so that's outside, exterior. Intrusive, plutonic, sometimes it's also called interior. Over here, we have obsidian, pumice, vesicular rhyolite. If we look over here, vesicular means that it contains gas pockets. Okay, if you've ever seen pumice, it has a lot of holes in it. I'll show you some in class. That's what it's talking about. Uh, they can be non-vesicular, vesicular, they can look glassy. These are generally non-crystalline. This is our basaltic glass, scoria, pumice, and obsidian. We also have vesicular rhyolite, granite, and pegmatite. Vesicular andesite, and diorite. And then vesicular basalt, diabase, and gabbro. And then here, peridotite and dunite. And it also, over here with the texture, there's fine, there's coarse, and there's very coarse. So the way this works is you find, say, obsidian, you go across non-crystalline, it's going to be glassy and non-vesicular. Okay, I showed you that obsidian. Pumice, we go across, kind of glassy, but it also has gas pockets. Granite, which I showed you, if we go over, it has coarse grains and it's non-vesicular. It does not have gas pockets, so that's why we could see the crystals in it. Okay, I will show you some basalt in class, and if we go over, that has a fine texture to it. Now, we also talked about felsic and mafic. So I'm going to go down here a bit. Actually, let's just adjust it. Yeah. So here, the color is generally lighter for our felsic, and it says rich in silicon and aluminum, just like I told you, and they are lower density. Over here, darker, higher, mafic, rich in iron and magnesium. So that's how this scale works. And if we look at it, we can see the mineral composition of these for the most part. And we can see why the felsic are lighter in color because they're made of potassium feldspar, which is pink to white, quartz, clear to white, plagioclase feldspar, white to gray. But remember that granite had specks of black in it? That's from biotite and amphibole, which are both black. And so these tend to be our felsic. And so the felsic ones are on this side of the line, really. These are kind of intermediate in between the two. And we can see that granite and obsidian that I showed you before are felsic. All of these up here are felsic. If we go over to this side, we have the mafic side, which is darker and higher density. We go up and we see that these are all the mafic igneous rocks: gabbro, diabase, basalt, scoria, basaltic glass, okay? And I will show you some of these in class. And we see that the mineral composition, why these are so dark, there's some black here from the amphibole. Pyroxene and olivine are both green, okay, like olive green, olivine, and plagioclase feldspar, which is white to gray, which might lighten them up a little bit, but darker minerals make up the mafic, and lighter minerals make up the felsic rocks. So that's how to use this chart to look at this. And we'll be using this in class. We're going to be working on identifying some igneous rocks, and I'm going to show you some samples, and we'll talk about where everything falls on this chart. So this is page 6 right here in your reference tables. Okay, so to wrap this up and revisit our objectives, we've defined and identified some igneous rocks, and we're going to do more of that in class, especially the identifying part. We've described how the cooling rate of magma affects the texture of igneous rock, and we have classified igneous rock according to mineral composition and texture. And again, we'll be doing more of that in class. So next up are going to be sedimentary rocks. Do not forget your 5 questions that you have to write about this section.